Hey 8th graders, welcome to your 8th video. In this lesson what we're going to do is we're going to talk about Chapter 1, Lesson 8, Roots. And we're also going to talk about Chapter 1, Lesson 9, Estimating Roots. So we're going to combine two lessons in one for this video. Our objective for this video is we're going to find square roots and cube roots. Our standard is 8th grade standard, equivalent expression standard number 2. Let's go ahead, copy our vocab on the next slide. One of our first key concepts that we're going to talk about in this lesson is the idea of a square root. A square root of a number is one of its two equal factors. So a square root is when you have two of the exact same numbers that multiply to make one number. Again, they have to be equal factors, which means they have to be exactly the same. So the statement, if algebraically, says that if x squared equals y, then x is a square root of y. So an example of how that actually works using numbers instead of algebra is if I had 5 to the second power, well 5 times 5, that's 25. Since 5 and 5 are exactly the same, 5 is a square root of 25. A square root is when you have two of the exact same numbers multiply to make one number. That number that multiplies to make the number, that's the square root. So it's two of the equal factors. One of its two equal factors. So what you're going to do on the next slide is you're actually going to copy down the list of perfect squares, because we're going to be using perfect squares to be able to solve problems instantaneously. And then later on, we'll be talking about perfect cubes. You've already copied the definitions of those, but we're going to actually look at what some of those are. So on the next slide, copy down your perfect squares. Here we have our list of perfect squares. Make sure you copy them all down. I would like you to know, or if you could, memorize 1 through 15. Now I know some of you probably know some of these. 1 times 1, that's 1. 2 times 2, that's 4. 3 times 3, that's 9. 4 times 4, 16. 5 times 5, 25. And they continue on. Remember that a square is when you multiply by the exact same number to equal a number. So based off a rule of square root though, if I want to know the square root of 225, it's this number right here. The square root of 225 is 15. The square root of 196, 14. The square root of 169, 13. Because a square root means two of the exact same numbers that multiply to make a number, the number that's our perfect square is the square root. A square root is two of the exact same numbers that multiply to make that one number. So it's that one number that's exactly the same. The square root of 64, 8. So make sure you have these, because now we're actually going to use our perfect square and our square root rules to solve some problems that involve square roots. In our first example, I'd like you to try to find the square root without actually using a calculator. A reminder, a square root means two of the exact same numbers, but it's actually one number. So two of the exact same numbers that would multiply to make 64. What two numbers do you know in mathematics, multiplication-wise, equal 64 when you multiply them? Now a reminder, they have to be exactly the same. If you remember the previous slide, we talked about perfect squares. A perfect square is two of the exact same numbers, that's a whole number, that multiply to make one number. And 64 is a perfect square. So since it's a perfect square, what two numbers do we know make 64 that are whole numbers? 8 times 8. So we know that 8 times 8 is 64. So that means that 8 squared equals 64. Since 8 squared equals 64, 8 is equal to the square root of 64. And that's our answer. Because 8 times 8 is 64, and two of the exact same numbers that multiply to make 64 is 8 and 8. Since it's the 8 and they're exactly the same, 8 is our square root. In example 2, we're still going to be doing square root, and this time we're going to do the square root of 225. So square root of 225 means two of the exact same numbers that multiply to make 225. Think about the number 225. That is one of our perfect squares. Since it is a perfect square, I know that 15 is the square root of it, because I know that if I take 15 times 15, I'll get 225. So 15 is actually our answer. It's the number that multiplies by itself to equal 225. 15 times 15, 225. Square root again means two of the exact same numbers that multiply to make this number. All you gotta do is tell me the number that those two numbers both are. They're both 15. That's my square root. In this example, what we're going to be doing is we're going to be finding the square root of a positive answer and a negative answer that make 1.21. Now, to me, this kind of looks like the number 121. Well, I know that 121 is a perfect square. Now, if you don't know what the square root of a number is, you guys have these calculators that you can use in class that all you got to do is press the second button, you press x squared, because if you press the x squared button, it's actually going to give you this, which is your radical sign. And then you're going to type in 1.21 and press equals. And that's going to give you a decimal. One of the things you have to understand about a square root is that a square root is the positive number as well as the negative number, because two of the exact same negative numbers that multiply to make one number will make a positive. So I'm going to go ahead and type in my calculator the square root of 121. So type in my calculator, I'm going to hit second x squared 1.21 and press equals. And my calculator says that the square root of 1.21 is equal to 1.1. And that to me is kind of no surprise, because 11 times 11 is 121. So 1.1 times 1.1 would be 1.21. Now, this answer is not just 1.1. This answer is a positive 1.1, or it's a negative 1.1. And that's because two positives will make 1.21, and two negatives would also make 1.21 if I multiply them. If I type in my calculator 1.1 times 1.1, I get 1.21. And if I type in my calculator a negative 1.1 times a negative 1.1, I again get a positive 1.21. So both of these numbers, which are exactly the same, multiply to make this decimal here. Again, a square root is when you find the exact same number that multiplies by itself to make one number. Well, the two exact same numbers that multiply to make 1.21 is a positive 1.1 or a negative 1.1. I know I need both the positive and negative answer because this sign says they want the positive answer as well as the negative answer. So in this case, our answer is right here. A positive 1.1 or a negative 1.1, those are our square roots of 1.21. In example 4, we're going to do one just like the previous problem that we just did. If you feel like you can do this on your own, by all means, go ahead and do this on your own. I'm going to go ahead and work this problem out. Again, if I cover up that decimal, that looks like 144. Well, I know the square root of 144 is 12, so I'm guessing my number has to deal with a 1 and a 2. I'm going to use my calculator to double check. I'm going to hit second. I'm going to press the x squared button, which is going to give me the radical sign here. And then I'm going to type in 1.44 and press equals. Since this problem says plus and minus, they want the positive answer as well as the negative answer. So again, I'm going to go ahead, type this in my calculator. The square root of 1.44, I get 1.2. There's that 12 that I was talking about. So I know my answer is a positive 1.2 or a negative 1.2. Both of these answers would be correct on this problem. I know that 1.2 times 1.2, 1.44. Negative 1.2 times negative 1.2, again, a positive 1.44. In example 5, we have something a little bit different than what we were just working at. So we have a negative square root of the fraction 25/36. So what we're going to do is we're actually going to do a double square root. So whenever you see an entire problem underneath the radical sign, what that means is you're actually supposed to take the square root at the top divided by the square root of the bottom. So this right here is actually the square root of 25 divided by the square root of 36. But since we have a negative in front, we just want the negative answer. So we're going to make this answer a negative number. Well, we know that the square root of 25, based on the fact that it's a perfect square, that equals 5. The square root of 36, that equals 6. So our answer is a negative 5, 6, because we want the negative answer. And that's all we got to do for this problem. Anytime you have a large square root and there's a fraction on the inside, make sure you take the square root of the top, square root of the bottom, and solve that problem. In this example, just like the previous one, if you feel like you can do this on your own, by all means, please do it on your own. I'm going to go ahead, solve this problem the same way we just solved the last one. So, since I see the whole thing's under a square root, I know that I'm going to take the square root of the top, which is 49, and the square root of the bottom, which is 64. Since there's a negative, we know that we want the negative as our fraction. So I know that I am going to have a negative number. The square root of 49 is 7. Square root of 64, 8. So this entire problem equals a negative 7/8. Again, I knew that this was a perfect square. I knew this was a perfect square. That's how I got those answers. If you don't, you can always use your calculator, that second button, the x squared, type these numbers in and get those same numbers that we got here. But your goal is to learn those perfect squares, so this makes it a little bit easier. In example 7, we have another type of problem. This time it says we're going to find the square root of negative 16. So we need to think about what two numbers exactly the same will multiply together and make a negative 16. Again, they have to be exactly the same. Some of you are probably thinking that the square root of negative 16 is 4. Well, let's think about that. If I have 4 times 4, I do get 16. But what type of 16 is on the inside of this problem? That's a negative. So let's try a negative 4 times a negative 4. Because again, our numbers have to be the same. Well, negative 4 times a negative 4 equals, again, a positive 16. And in order to be able to actually get this answer, we need to have two of the exact same numbers multiply together to make a negative 16. I want you guys to go ahead and do something else if you haven't done it already. I want you to go ahead and press second. I want you to press your x squared button to get your little radical sign. And I want you to type in that problem right there. So I'm going to go ahead and do that myself. So I'm going to type in my calculator. Okay. Square root negative 16, press equals. Well, my calculators tell me that there's an error, and it's not working. And the reason why there's an error and it's not working is because you cannot take the square root of a negative number. Because two of the exact same numbers that multiply together will never, ever equal negative. Two negatives will always be a positive. Two positives will always be a positive. In order for them to ever have a negative, one has to be negative, one has to be positive. And that's not allowed because in a root, we have to have two of the exact same. So this has no solution. Because you cannot have two of the exact same numbers, multiply them by themselves to equal negative 16. So square root of a negative number, not allowed. On to example 8. I'd like you to go ahead and try this problem. Square root negative 81. See what you come up with. Hopefully you're thinking about the fact that we just did a problem like this and we really can't do that. So there's no real solution right now. Later on in math, you guys are going to learn something called imaginary numbers, but for right now, no solution. Or you could write the words that there's no real square root. Because right now, there's no two numbers exactly the same that will multiply together to make negative 81. So in this problem, no solution or no real square root, that's good to go. In example 9, we're going to be solving the problem t to the second power equals 169. Then we're going to check our solution. So first, I'm going to write the problem that I see. I have t to the second power equals 169. Well, what I'm going to do is I'm going to teach you there's a trick. In order to get rid of a square, you're going to take a square root. In order to get rid of a cube, you're later going to take a cube root. For right now, we're going to get rid of this square because our job in the math is always to solve for the variable. So we're going to get rid of that square by taking the square root. Well, in mathematics, they say that if you take the square root of one side, you have to take the square root of the other. Because in math, If you do something to one side, you have to do something to the other. And by sides, I mean the equal sign. What the equal sign does is it separates the left side of an equation from the right side of the equation. So, while I have a square and a square root, what those two things are going to do to each other is they're going to cancel each other out. I now know that t is going to equal the square root of 169. Well, I know the square root of 169, since that's a perfect square, is 13. So t equals 13. Since it says the square root of 69, I'm going to say that t is the positive or negative 13. Because they didn't ask me if they wanted a positive answer or a negative answer, I'm going to say that it could be the positive or it could be the negative for this solution. If I take a negative 13 times negative 13, I'll get a positive 169. If I take a positive 13 times another positive 13, again, I'll get 169. So my answer to this problem is t is equal to plus or minus 13. So 13 to the second power should be 169. I could check that in my calculator and see that I'm correct. Let's try another one. In example 10, we're going to be solving the problem x to the second power equals 225. So we have to figure out what number to the second power will equal 225. So we're going to kind of set it up the same way. We have a number to the second power equals 225. I want to solve for x, which means I want to get rid of this square. To get rid of a square, we're going to take the square root. In math, if we do something to the left side, we have to do something to the right side. So since I took the square root of the left, I'm going to have to take the square root of the right. Well, the square root and square cancel each other out. So now we have the variable x. And again, since I know that the square root of 225 is a perfect square because I know my perfect squares, the square root of 225 is 15. And since this didn't tell me if they wanted the positive answer or the negative, I'm going to put plus or minus here, which means that I'm satisfying both the positive as well as negative answers. That's it for square roots. Let's move on to cube roots. So we're going to copy down our key concept. We're going to look at some perfect cubes, and then we're going to practice some more problems, and you guys are almost done with this lesson. For our key concept of the next part of the lesson, which is going to talk about cube roots, we need to know the definition again. You've already copied down the vocab once. It's just here again. A cube root of a number is one of three equal factors. So instead of it being two of the exact same numbers, now we're looking at three of the exact same numbers. So the statement in algebra states that if x to the third power equals y, then x is the cube root of y. An example of that, if we know that 2 to the third power is 8, then 2 is actually the cube root of 8. So if I take 2 times 2 times 2, I get 8. 2 is the number that would be exactly multiplying by itself 3 times to make 8. The number that multiplies by itself 3 times to make the number that we get, that's the root, the cube root. Let's go ahead and start some problems, but before we do that, let's write down some perfect cubes. For perfect cubes, I'd like you at least to maybe try to remember these 10 here. Instead of 15, we now got 10. 1 to the third power is 1. 2 to the third power, 8. 3 to the third power, 27. 4 to the third power, 64. 5 to the third power, 125. 6 to the third power, 216. 7 to the third power, 343. 8 to the third power, 512. 9 to the third power, 729. And finally, 10 to the third power is 1000. If you don't remember these, that's okay. This is something that you can use to reference. If you ever have something that is a perfect cube, you can find out that the cube root of that number is the number you started with. So a perfect cube is when you get a whole number that multiplies by itself to make this number here. So in this case, if I have 7 times 7 times 7, I'll get 343. 7 is the whole number. Perfect cubes are whole numbers that multiply together 3 times by themselves to make the numbers that we get here. Now there's many other perfect cubes. You can do 11 times 11 times 11. You can do 12 to the third power. You can do 13, as much as you want to any power of 3. And those are perfect cubes as long as they're whole numbers. These are just the 10 normal ones that we would maybe try to remember. Alright, example 11. I know we've done a lot of examples. What we're going to be doing is we're going to be finding the cube root of different numbers. Now notice that there's a number 3 inside of our radical sign. That means we're going to take the cube root. If there was a 4 inside the radical sign, that means we'd be taking the 4th root. We could put a 5 inside the radical sign and even take the 5th root. What that root tells us is that root tells us how many of the exact same numbers we want to multiply together to make the number that's in here. So we want 3 of the exact same numbers that we know multiply together to make 125. If you remember the list that we just copied down on perfect cubes, this answer would be 5. So the cube root of 125 is 5. Now, if you didn't know that, you guys have these awesome calculators that you get used in class. What you would do is you'd press 3, which tells your calculator you want to take the 3rd root. You're going to press second, and then you're going to press the root, or the exponent button, but instead of it actually showing up as an exponent, it's going to show up like this. Notice that there's an x inside the radical sign. The x is telling your calculator that the 3 is the number you're putting in for x, which tells your calculator you're taking the 3rd root. Then all you got to do is type 125 for 125, press equals, and your calculator will tell you that 5 is the answer. So if you type in the 3rd root of 125 in your calculator, you should get 5 as your answer. And in this case, it's not the positive and negative, it's just the positive. When you're doing something to the 3rd root, it's either going to be a positive answer or a negative answer. Let's go ahead and do another problem. Reminder, you can use your calculator if needed by pressing these buttons if you have them. If you have a button that says this on your calculator, if you're not using the ones at school, you can press the number, press the button that looks like this, and then type in your number to get that same number. The other method, guess and check, or learn your perfect cubes. Let's go ahead and try another problem. In example 12, we're going to find the cube root of 27. Notice again, there's a 3, which means we're finding 3 of the exact same numbers that multiply together to make 27. If we know our perfect cubes, we could get this answer, or we could type in our calculator by pressing 3, second, the exponent button, it should look like this, and then we type in 27, press equals. Since I know my perfect cubes, I know that the cube root of 27 is 3, and that's my answer. Hopefully, this is making sense to you. If you want to check yourself, you could always type in your calculator 3 times 3 times 3. Again, notice it's 3 of the exact same numbers that multiply together. 3 times 3 is 9. 9 times 3, 27. So 3 is the cube root of 27. Now, I know what you're thinking by looking at this. You're thinking that it's not possible. You can't have a negative inside a radical sign, or this square root sign. And in this case, you can, because what we're actually doing is instead of taking 2 of the exact same numbers, we're taking 3 of the exact same numbers that would multiply to make a negative 27. Well, we just did a problem where we found 3 of the exact same numbers that make 27, and the answer was 3. So 3 of the exact same numbers that would make a negative 27 would in fact be, instead of a positive 3, a negative 3. So if I were to type in my calculator negative 3 times negative 3 times negative 3, I know a negative times a negative is a positive. That's why it doesn't work with 2. But a positive times a negative is a negative. 3 times 3 is 9. 9 times 3, 27. So when I multiply all 3 of these numbers, which are exactly the same, I do get negative 27. So in this case, negative 3 is the cube root of 27. You are allowed to have a negative inside a cube root. You're not allowed to have a negative inside a square root. If you wanted to check yourself, you can still type it in the calculator doing the same method. And instead, in here, you would type in negative 27 and press equals and see if you get the same answer that we got here. Example 14, kind of like what we just did. I just added another one just to see if you guys could do it. It's the cube root of a negative 1,000. Again, since we're taking the cube root, you can find the answer to this. 1,000, hopefully if you remember from previous screens that we do know perfect cubes, that is a perfect cube, which means whole numbers will multiply to make that number. If it wasn't a perfect cube, you could definitely use your calculator to get to that perfect cube answer, or get to that number that we're looking for. So in this problem, we have 3, or the 3rd root of negative 1,000. Well, I know that the cube root of negative 1,000 is a negative 10, because negative 10 times negative 10 times negative 10 will equal a negative 1,000. 3 negatives is a negative, and 10 times 10 times 10, 1,000. So negative 10 is my third root of 1,000. You guys did awesome today. We're going to do one more problem, and we're going to call it a day. I was going to do a second lesson. I feel like this was long enough. If we need to, I can start teaching the next lesson in class, but I feel like you guys did awesome, so let's do one more and call it a day. And our last example, your favorite, my favorite, word problems. Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. Solve the equation. 8 equals s to the third power. We're going to find the side length of s of the container. So they want us to actually solve this equation. 8 equals some number to the third power. Our job is to find out what this number is to the third power that equals 8. So what we're going to do is we're going to write that problem down. 8 equals s to the third power. Just like we did with square roots and something to the second power, we could actually get rid of a cube by taking the cube root. So what you do is you take the cube root of the left side and you take the cube root of the right side. To get rid of a cube, you take the cube root. To get rid of a square, take the square root. So if I want to solve this problem and I want to get rid of something to the third power, I take the root of something to the third power. So a cube root and a cube cancel each other out. We now know that the cube root of 8 will equal s. So now, all we have to do is figure out what 3 numbers exactly the same will make this number here. So we could type in our calculator by pressing the second, the exponent button, and then typing in 8, and after we press 3 for the root, and see what happens. I'm not going to do that. I know that 8 is a perfect cube. So now I know that 2 times 2 times 2 equals 8. So s is going to equal 2. One side length is going to be 2 feet. And that's it for today. You guys did awesome. Make sure you smash that like button. If you haven't, hit that notification bell, and I will see you tomorrow.